All right, we're on to our 2-2 video. So if you're watching this right now, you should be following along, taking notes in your workbook on pages 36 and 37. If you're watching this now, you should have also already done the critique and explain either in your workbook or on Sabbath. Question 1 only. Our goal today is to write and graph linear equations, but now in point-slope form. So lesson 1 was about slope-intercept. Now we're doing point-slope form. If I look back at my vocab, the point-slope form is y minus y1 equals m times x minus x1. So if we move on to question 1 in our workbook on page 36, it asks, why is it helpful to have point-slope form and slope-intercept form, right? Why do we have two different versions of the same equation? And the answer is each form gives us different information. Really, they are the same equation rearranged. And then what the information that they give us is in the name, right? So point-slope form gives us a point. The point is x1 comma y1. And it gives us the slope, which is m. And slope-intercept form gives us m, and it gives us the y-intercept, which is b. If I imagine an example of point-slope form, maybe like y minus 2 equals negative 5 times x minus 4. From that equation, I can pick out the slope, m, my x1, my y1, and that tells me a point on that line is at 4, 2, x, y, and then I know my slope is negative 5. Similarly, if I had an example of an equation in slope-intercept form, I would be given different information. So maybe y equals negative 5x plus 22. That would give me the slope is negative 5, but it also tells me my y-intercept is b. So I have a point at 0, 22. So it just gives me different information. Both are just different versions of the same equation. Actually, these two equations are the same. Those are the same equations from the critique and explain. And the different forms of the equations all come from the same place, which is the slope formula. So look at our notes. I wrote the slope formula there from our last lesson. M equals y2 minus y1. That's my rise. Over run is x2 minus x1. If I was to rewrite that by solving to get rid of that fraction, by like multiplying, right, doing the opposite of dividing, multiplying by x2 minus x1 to cancel out that fraction, and if I do it to both sides, because if I do something to one side, I have to do it to the other, I would get m times x2 minus x1 equals y2 minus y1. So that is my point-slope form, and that's where I get it from, my slope formula just rearranged, and then I substitute in x and y for x2 and y2, because x and y are variables that represent all the values of x and y. x2 and y2 are specific constants from just one point. So now I have my form. So all my forms are coming from my slope formula. We're going to use the slope formula in example number 2 to write a point-slope equation given 2 points. So it's easy to know what information I need given the name, right? So if it's a point-slope equation, I need to first find my slope and then also a point, right? So what is my slope? And 2, what is a point? x1 comma y1. So I need a point and slope, and I'm going to write out my form again. Y minus y1 equals m times x minus x1. So again, in my notes, I have the slope formula because that's what I'm going to use to find the slope. My slope formula is y2 minus y1 over x2 minus x1. And I get those values from labeling my points. Every point is an x and a y coordinate, x and y. I remember what comes first because x comes before y in the alphabet also, w, x, y, and z. And then my first point is 2, negative 1, so that's going to be x number 1 and y number 1. That's what those little subscript numbers are for. My second point will be x number 2 and y number 2. Now that they're labeled, I can substitute in those values. So y2 is 3 and y1 is -1. So if I go to calculate that, I would do 3 minus -1 over x2 minus x1, so -3 minus 2. I'm just getting those numbers from my 2 points. And then I'm going to evaluate. Minus a negative is the same as plus. So 3 plus 1 is 4 over -3 minus 2 is -5. A better way to write it is just with the negative sign to the side, -4 over 5. That is my m, my slope. And then the point is even easier. They're asking me for x1 and y1, and I already have x1 and y1, right? We already labeled a point as x1 and y1. I could use the other point. I just can't mix and match numbers from 2 different points. So that means that my x1 is 2 and my y1 is -1. If I go to put this in my format, again, kind of like fill in the blank, right? Y and x are my variables, so they stay, but y minus blank equals blank times x minus blank. Looking back up at my form to know what those blanks are for, right? It's y minus y1. We know y1 is -1 equals m, which is -4 over 5, times x minus x1, which is 2. That is my form. If I want to rewrite it a little bit more simplified, I could also, instead of that minus a -1, change that to plus again. Y plus 1 equals -4/5 times x minus 2. And that is a great final answer. Again, remember that x and y are my variables. Those represent all the values of x and y throughout my entire line versus x1 and y1, those are constants. That's a specific point, 1 point. So that's a number. We're again going to do my second part of the goal, which is to sketch a graph now, given an equation. And the steps are the same as in lesson 1 with the slope-intercept form. But now we're using the form y minus y1 equals m times x minus x1. And the first thing I notice is that my format of my example doesn't match perfectly with my point slope form, because in my form it says y minus y1, a number. But in my example, I have y plus 2. So if I want to have an easier time identifying my y1, I might rewrite this as y minus a number equals 1/2 x minus 3. But how could I subtract a number and still be equivalent to y plus 2? The only thing that's the same as y plus 2 using a minus would be y minus a -2. We talked about that. Minus a negative is the same as plus 2. That way, it's a little bit easier now for me to identify what is my y1 and what is my x1. My x1 is 3, and my y1 would be -2, because I'm doing y minus my y1. And then my slope, I also have my slope is m. That is in the m spot. I have 1/2. So that means 1 is my rise. So since it's positive, I'm going to go up 1. And 2 is my run. And since it's positive, I'm going to go forward 2. So looking at my steps, same steps as in lesson 1 in my notes, I want to place a point at x1, y1, and then use my slope, the rise over run, to find the next point. So let's set up my graph. I already did my y-axis straight down through the middle and my x-axis side to side through the middle. And I'm going to place my point at x1, y1, right? I have a point at 3, -2. So I'm going to go over 3 on the x-axis, 3, and down 2 on the y-axis, -2. And that's where my first point is going to be. Then I'm going to use my slope, rise, and run to place the next point. So I'm going to start at that point, 3, -2. I'm going to rise 1. I went up 1. And I'm going to go over 2. And that's going to be where my second point is at. 2 points is plenty. I can draw a long line through these 2 points. I could keep doing my slope to place more points. It should be the same slope all across this line. I'm going to trace a long line through those points, arrow on both sides to show it goes on forever. My slope is a constant. So all across this line, I'm going up 1 over 2, up 1 over 2. So finally, we're going to end with a word problem. The word problems are a little bit confusing because there is some details that are missing from this that are only in the textbook. So maybe like we talked about the pages of the textbook, you can look at those, pages 63 through 65. But either way, we can still answer this. So what it asks us to do, it says the point slope form of the equation for the total cost of Marissa's quinceañera is y minus 725 equals 12 times x minus 50. Rewrite this point slope form equation in slope-intercept form. What does the y-intercept represent in the situation? That's the part where we don't have any information about the situation, but I noticed it is in the textbook. So, but in my notes, so that's my difference of my point slope and my slope-intercept. So we want to go from point slope to slope-intercept. Notice slope-intercept is solved for y. It's always y equals mx plus b. So that's all we want to do. We want to solve for y. So with my equation, I'm going to try to get y by itself. First, I'm going to distribute with that parentheses because then when I add or subtract to both sides, I know what I'm adding and subtracting to, so I'm going to multiply, right? So my dot for multiply, 12 times x is 12x. 12 times negative 50 is negative 600. Still equal to y minus 725. Didn't change that at all, so I just bring that down with me. Now to get y by itself, I'm going to do the opposite of minus 725 and add 725 to both sides. I'm going to add it to the other constants. Oh my gosh, I left off the x. 12 times x is 12x. So when I add it to my negative 600, that would be the same thing. I could also switch the order and do plus 725 minus 600. That always helps me remember. I'm just subtracting. I would get 125. So now I have y by itself equals 12x plus 125, and that is my y equals mx plus b. My m is 12, and my b is 125. So that's my final answer, and my b is 125. What does that represent in the situation? Again, we don't know, but always my y-intercept should be a one-time fee when we're talking about money, right? They said we're talking about cost, maybe a deposit, something like that. Similar to our pizza question, the y-intercept was the delivery fee, which is just a one-time. Different than the slope. See here, 12 is multiplied by x. The number multiplied by x is going to be going up for every x. Maybe if x is the number of guests coming to our quinceañera, maybe the price is going up by 12 for every guest, but it starts at 125, something like that. So even though we don't have the details, we kind of have an idea. If you want to see more examples of point slope form, you can pause the video here to look at this from the textbook. I think those are great examples. They do a cool job of like color coding different parts of the equation in the graph. After this, you should be moving on to the Do You Understand, which is in page 38 of your workbook. You did not have to do the Do You Know How, but if anybody wanted to try, maybe it would make really good notes for your workbook. Maybe you're trying to study or trying to get prepared for a quiz or a test. These are my answers. They can vary a little bit, so feel free to ask questions, but you can pause the video here to see those answers. Either way, now you should return to your checklist and update it because now you're done with the video, and now you're going to move on to the Do You Understand? Taking notes in your workbook on page 38. Good luck.